Hi, day 170. Okay, we're going to look at Ohm's Law and circuit schematics and magnetism today as we build towards this goal of making a motor out of magnets, wire, and a battery. Just some really basic stuff. And there's a decent shot that you have these things at home, which is why we're going to do this. Because I want you to see how you can make a really basic motor. It's pretty cool. Okay. Before we get into that, some basic housekeeping stuff. It's almost the end of the school year, and so there's a few things that you need to do. And I've given you a link. I mentioned this in a remind message a couple days ago, but if you go here to the Venice website, there's a schedule for when to show up to return your items, books, anything else you've checked out. Maybe you have like a calculator for a math class, or maybe you checked out a laptop. The times to bring those back are here on this link, and they're by last name. And yeah, so check those out. And if you have any questions, feel free to let me know. Okay, so other housekeeping stuff. So we're gonna have a final, and the final will be a traditional test, and should take about an hour, maybe an hour and a half. The final review is up. I don't know that I put it today. I did put it here today. It's also yesterday. I put it out on day 169. So, and the answers are there. If you're feeling like you're ready to take the final on Saturday, I'll have the final available sometime on Saturday. If you don't feel like you're ready, then you want some more time to review, Sunday, Monday, or Tuesday. So Saturday, Sunday, Monday, or Tuesday, that's when you can take the final. I know some folks have a couple tests on one day. The administration took our finals window and shortened it quite a bit. Took it from 3 days down to one. So, yeah. So this is how we're going to work around that. Okay. So how many goals for today? Cuarto. We've got solving Ohm's Law problems and identifying some circuit schematic components, which should be easy because you've been doing the FET circuit practice. Draw some simple circuits, and then answer some questions about magnetism. So those are all things you should be able to do by the end of the period. So for the warm-up, two things. One, you should define schematic, and two, you should solve these two problems. So before we do that, let's talk about these problems real quick. The first one asks you, what is the resistance? We're talking about an electric frying pan. It says it draws 12 amps of current when connected to a 120 volt circuit. 120 volt circuit is what you have in every house or apartment here in the United States. It's the common voltage for a household. So that's the pressure in the electrical lines, and this is the flow, right? 12 amps of current, that's the flow. And so we want to know what the resistance is for a device. And electric frying pan, if you've never used them before, it's like an electric stove. It has a coil of wire that looks like a spiral, and that wire is really resistant to letting the electrons or the charge flow through it. And think about when things are resistant, right? We always do this hand thing. If you push your hands together really hard and you try and slide them past, they get hot or cold. Hot, right? And so that's the result of friction. And this is what's happening with electrons in an electric frying pan, in an iron, in a heating blanket. If you have a steam mop, same thing. So they all have resistors in there, and those things resist the flow of electrons and therefore get hot. So figuring out the resistance there is problem A. Problem B, how much current if you know the resistance of a lamp and you know the voltage being pressed or across it or pushed across it. Excuse me. So those are the two problems. So try them out and then come on back. Okay, got the answers? So schematic. What's a schematic? It's one of these. A simplified drawing which uses symbols to explain how something works. So like in here, it's probably not reload. Oh, you made some schematics. All right, I asked you to draw a circuit with a couple of bulbs in it. And then from there, you were supposed to analyze what happened when you had a parallel circuit and a series circuit, and you added more bulbs to it. You're supposed to say what happens, and so in doing so, you were using a schematic, especially if you took all these pieces over here, and when you connected them, if you let's put one of these. So if you turned this off and you turned, hey now, there we go. Turn that on, you can see you've got a few things here. Maybe I'll add another piece of wire to make this easier to see. There we go. Whatever. Anyway, so circuit diagram. Here's one. We've got a battery with a single cell. We've got a lamp, all right, a light bulb. We've got a switch. So this is our schematic. And if you were working on a car to repair the wiring, or trying to figure out why it's not working, and you're trying to follow a wiring diagram, you'd be looking at something like this, but way more complex. And so understanding those things can be really powerful. Like I said, you can use it to fix your own car, or to understand what might be wrong with your car, so you can do some troubleshooting, and especially if you have an older car. And you can even use it to do some work on your house, like running a new circuit in your house and doing it right, so that you don't have any problems. And that can save you hundreds of dollars over your life. So it's cool stuff. Okay, so let's answer these two questions. I've got the answers here. So what we're working with this equation, which is Ohm's law, and it says that current, I, is equal to voltage divided by resistance. And what does that mean? Well, remember, voltage is pressure and resistance is friction. So, and current is flow. So think of it as the harder you push, the more things flow, right? If I push on the air through like a straw, right, the air flows faster through that straw if I blow harder. But if there's more resistance, like maybe there's a bunch of little, I don't know, maybe put a pipe cleaner inside that straw. So there's a bunch of little fuzzy hair like things in there. When I apply the pressure, it resists. And so there's going to be less flow, less current. So that's Ohm's law. We can write it in a bunch of different ways to solve for any of these three variables. Here's a common one. I always memorize this as just VIR, V-I-R, and then from there I could just flip it around, rotate it around to get the other stuff. Okay, we want to know resistance. We know current and voltage. So if we want to know resistance, we have to get this by itself. And so that means this has to go where the current is, and the current has to go down there. It's kind of the flip-flop thing you do with fractions in algebra. So we've got our equation here. And when we plug in, there we get 120 volts divided by 12 amps. And the unit of resistance is going to be ohms, which looks like this upside-down horseshoe thing, 10 ohms. Next problem, we know the resistance, we know the voltage, we want the current. Current is voltage divided by resistance, and so it's 50 volts divided by 100 ohms, or half an amp. And that's the two problems. Okay, so in the Ohm's law practice, there are a number of problems, 8 actually, that look just like this. And they should be about the same, right? Again, just getting you comfy solving basic problems using Ohm's law. We've got a problem with voltage and resistance. You got to find the current. Here you're given the current and the resistance, find the voltage. Here we're talking about a 9-volt battery. The little rectangular ones that you put in your smoke alarms and sometimes in remote controls and things like that. So you can figure out the size of a resistor based on the current that goes through it, and a few other problems. When you're done with those, we're going to do a little bit of a circuit schematic. And so that looks like this. And these images should, again, feel familiar to you because you've been here, right? And you've played around with this. So, So again, a schematic is a drawing that's simplified. It's not a picture of what things actually look like physically. It's just it's a drawing that shows the objects in the system and the orientation of those objects, right? Um, these things don't necessarily have to have all these right angle corners. It's just showing that we're going from this thing. What's this thing? I gave you a link to a bunch of schematic symbols. So what's this thing? Well, it's a battery. And identifying some. So we got a V, this squiggly thing, and this guy. You should know that this is a battery. You're going to want to memorize that. You probably already memorized that this is a switch. You probably don't know what these things are. And you might know that this is a resistor. So the A stands for this. It's an ammeter, and the V is for a voltmeter. And I actually have this thing. Show it to you today. This is a multimeter. It does all that stuff. But you might find some circuits where there's some kind of amp meter that's located in the circuit, and it's always there to monitor the current flowing through the system, so that the system doesn't get overloaded. And so that's what this picture. That's what this picture is showing, and it's also showing that you're using the voltmeter and using the two prongs to go. Right, one here and one there. Right, you're using both these things to span this resistor, one on one side, one on the other, just to see what's going on with the resistor, like how what the voltage is across it. Because once you know the voltage across it, you could figure out the resistance, right? How much it's resisting, especially if you already know the current from right here. Right, this gives you two of the three pieces of information, and from there you can figure out the third. So there's a few questions about those things. Here's another circuit. This one, we're doing the same thing. We know the current. We know the voltage across resistor 1. That's why it's called voltage 1. And this is, again, a battery, but it looks a little different, right? That's because each of these little sets of short and long lines, they actually represent plates inside the battery. Each one represents a cell. So if you had a 4-cell battery, it would look like this. Yeah, so that's what that represents. Hey, dude. You want to see a circuit diagram? Yeah. This symbol is for a battery. That's for a resistor, and this is like a light switch.
Cool.
Yeah, bye. How's your lunch? All right. Okay, so that's the...
Where's my kitty tablet?
Your kitty tablet is probably plugged in over there. All right, last thing, some guided reading on magnetism. Well, I don't know, buddy. You're going to have to look around for it. Maybe it's in Mommy and Daddy's room. Okay. So some stuff about the history of magnetism and magnets and just their discovery is how this starts off. And then thinking about what happens when you break a magnet in half. Like, this is the north pole of the magnet, and that's the south pole. But what happens if you split it? Is this just the whole north and this is the whole south? Or how does that work? Turns out it's kind of interesting. Inside this magnet, there's a whole bunch of, it's molecules because it's not one element. And they all have an alignment. Like, they all get lined up. Psst. Shh. Daddy's doing work. They're all lined up. And when you break it, here you would have molecules that are all pointing in one direction. Let's say they're all pointing to the left. Well, let's imagine there was an arrow in here that was pointing to the left, like that. Okay. Well, the end of the arrow is here. And then here, there'd be more arrows also pointing to the left, also pointing to the left. It'd be full of arrows pointing to the left. So every time you break it, it's just those arrows get a little bit smaller. There's less stuff in there, but they're still all pointing to the left. Anyway, read a little bit more about it. It's interesting stuff. You get to see what a magnetic field looks like. Talk about Earth's magnetic field, which, if it wasn't there, we'd probably die or not exist. Fairly important. And yeah, even talks about magnetic field reversal. Some really cool stuff in here. Some really cool pictures showing how magnetic fields interact. So we'll start off with this. This is just one bar magnet on a piece of glass, and under that glass is some space. I imagine like two pieces of glass sandwiched together, and in between there are iron filings. Imagine you could take a cheese grater, and instead of grating cheese, that you could grate off little pieces of iron, kind of like when you sharpen your pencil, and you get those little pieces of lead that come out. This is like that. And they all get lined up based on the magnetic field. By the way, this looks a lot like an electric field, which you saw when you played electric field hockey. So we can see the field lines. They kind of curve around from north to south or south to north. Some of them go directly out from both ends, and otherwise they're curving around like so. And when you have two, sometimes if the poles are lined up, right, like this is north and north, you can see that they are repelling each other, right? These two are repelling, these are repelling. You get this line in the middle where stuff doesn't cross. These are going to fight really hard to not come close to each other. They're going to repel. And you can see that the field lines don't cross. Here, where they're opposites, this is north, that's south, that's north. You can see they're attracting, right? These are going to go like this, and they're going to try and stick together. So, some cool stuff with fields. Also, here you can see how the filings line up based on the field around the magnet. Neat biz. So, a little bit of reading, and then tomorrow and Monday we'll do a little bit more with magnetism. On Monday, I'll show you how to make a motor with some magnets and wire, and tomorrow I'll give you a list of materials that you can use at home to do this if you don't have all the recommended stuff. Okay? All right. Have a great day.